Okay, so in the last video we overviewed the approach that we're going to take for implementing our reflection component. In this video I'd like to begin to work on the implementation of our reflections pass, and what we're going to do in this video, we're going to set up reflections but just perfectly smooth surface reflections. We're not going to have the ability to specify how blurry the reflections are. We'll deal with that in the next video. So what we're going to do, we're going to create another environment map VOP just as we did for our lookup based off of the surface normal for our fill pass, but instead we're going to work out a reflected ray off of our surface and use that as the lookup. We can then output the color into a new pass, and that will give us the basics of our reflection pass. So let's jump over into Houdini, and I'm going to jump into our shader. Let's drop that down so we have a nice large work area. I'm going to jump inside our material, inside our shader, and I'm going to create a new environment map VOP, which I'm going to rename to env-map reflections. And this environment map, we're going to point to our crisp HDRI. So I'm going to go to my HIP, and then HDRI's reflections. And the way the convolution numbers are working, 256 original is our most crisp, our perfectly non-blurry image. And then the higher the number of the convolution, the less blurry it is. That means convolution underscore 001, that is a diffuse convolution, it's really blurry. And then the higher this value, the less blurry. So we're working from 001 being the most blurry through to 800 being the second to last in terms of least blurry. Original is the least blurry image. So we're going to just load in 256 underscore original.tiff. We'll deal with driving this parameter with a parameter on our asset in the next video so that we can select between these various images. So I'm going to grab 256 original.tiff and accept. I do want to make sure that we set our transform space to, and we can't see off the side of the screen there, but I'm going to set this to transform to world space so we get space world. This is important because our reflection vector may not be in world space. We want to make sure that it's put into world space before we use it as a lookup into that map. So all that we need to do is drive the direction input of this environment map with our reflected ray, our reflection direction R. Now we could take, as we discussed on the whiteboard, we could take I and we could take N, and we could use those to calculate R based off of our rule here where the angle of incidence is equal to the angle of reflection. However, I know that later on there's a VOP that we're going to be using as part of our diffuse reflection component balancing, that is the Fresnel VOP, and that actually, as part of its calculations, will calculate the reflected ray R for us, the reflection direction R for us. So I'm going to just simply create that VOP now, since we know we're going to be using it later, and take use and make use of the reflected direction R vector that comes out of that. So let's create a new Fresnel VOP. So there's our Fresnel VOP, and what it takes in is a normalized I, that is, we can see we have I, which is the direction of our eye into the scene, and we have N, the surface normal. It takes in a normalized version of I and a normalized version of N. That means each of those has a unit length, a length of just 1. However, by default, if we don't wire these up, then they are going to be hooked up correctly to I and N of our global variables. It's only if we wanted to drive these with different values that we'd need to make sure that these were normalized to get the correct outputs from our Fresnel VOP. So we've got our Fresnel VOP, and we're going to take the R output. It calculates the R output, which is our reflection direction. We can take that and use it as the direction, as the lookup into our environment map. It's worth pointing out the Fresnel VOP takes I and N. It calculates the reflection vector that we'd get from that. It calculates the refraction vector that we'd get from that. And then it uses the index of refraction partly to calculate the refraction vector and partly to calculate, well, how much of the light will refract and how much of the light will reflect. And again, we'll talk about this later on. We're not worried about any of this for now. All we're worried about is the reflection direction R. So we can take R and we can wire it into the direction of our environment map. With that, we can take the color output of our environment map and wire it into input 5 of our switch render pass switch VOP, and that gives us our newest render pass, if you will. So I'm going to bring up the type properties of our material, jump to render pass, and over on the menu tab I'm going to add a new entry into our render pass menu for this new pass, and this is our reflections pass, and accept, and then going to jump up to the output context, and on our render settings null I'm going to edit its parameter interface, and I'm going to repeat. So entry 4 is our reflections pass, and accept, and then let's create a new take. So I'm going to append the take to passes. This is our reflections take, and in this take I'm going to include our render pass from our null. I'm going to set this to reflections, and then what we can do, we can jump over to mantra, and I can tell it to render using reflections. And if we were to render, and I will bring up the task manager just to see when mantra finishes rendering. There we go, that's finished rendering. If we were to jump to our composite view, jump over to our image network, we could bring in our newly created reflections and take a look at those, and we can see here is our reflection pass. So again, to recap, we have our camera looking at our scene, and for each pixel that we're rendering we have a direction I that's basically the direction we're looking at into that scene. Now that direction vector is going to intersect with a point on our surface, and that point on the surface has a normal vector, and we can use that normal vector with our eye's direction vector to reflect where we're looking off of the surface. That reflected vector is what part of the environment we're going to see reflected in this surface. So we're going to use that reflected vector as a lookup into our environment map, and that gives us these reflections on our surface. So we can see in our teapot here, we can see our environment reflected on the surface, and obviously the viewing angle combined with the surface normal, the shapes, if you will, of our surface is going to dictate the reflections that we see in the surface. So it's a very easy pass to implement, but that is our reflections pass, or at least the basics of our reflections pass. In the next video we'll turn around and we'll add the ability to specify the blurriness of the reflections. Thanks a lot, everyone.